All right. So with just like with fractions, when you're adding fractions, things have to be alike. You have to have the same. When you're adding radicals, again, things have to be alike. It's always you're always more picky when you're adding and subtracting than when you are with multiplying and dividing. And so here, if we want to add or subtract, we need to have the same root in order to do so. So like on number one, that we have the square root of 7 in both terms, and so we can group them, and we do that by adding only or subtracting only the coefficients. So we have 9 minus 15, which is -6. And then don't add or subtract the radical, you leave just the radical alone. Okay, and so that would be our answer, -6 times radical 7. On number 2, would we be able to subtract those? So this is a cube root of 5, and this is a square root of 5. So in this case, okay, we could, I heard a yes, we could consider, like if we put it in the exponential form, well, that'd be 5 to the 1/3 minus 4 times 5 to the 1/2, but then where would you go? So can I multiply the 7 and the 5? No, because the order of operations says we have to do the exponent before we multiply, right? Well, you have, before you subtract, you have to do multiplication. So we're stuck, we're at a standstill here. So this is as far as we can go. Okay. On number 3, what would we get if we added these? Seven x square root 72y. Okay, and then you also want to keep in mind, can you simplify further? Can I break that 72 down and simplify this further? And 72 is 9 times 8. Or you could do 36 times 2, which might be easier to work with. 9 is 3 times 3. 8, you got 2 times 2 times 2. And so definitely we're going to be able to simplify this further. We got 7x already on the outside. And the part I'm going to be able to simplify is 3 squared and 2 squared. The part that's left is the 2y. And so we're going to end up with 7x times 3 times 2, which is 42. Okay. So after you add, also check, can you simplify further? We could have also simplified in the beginning, but that would have been, we had to do that twice. And so you can simplify in the beginning or at the end. Okay. On number 4, can we subtract those? Who said yeah? No? Yeah? No? Okay. So as is, like one's a cube root of 16, one's a cube root of 81. So as is, we can't. But maybe after we simplify them, maybe they'll have the same root and we can. And so even if we can't, we want to simplify stuff as much as we can. So this is 16, which is 4 times 4, or 2 times 2 times 2 times 2. And 81, 9 times 9, or you get 4 3s. Be careful when you're, from the last lesson, we just grouped everything. We cannot group everything in this one. Please keep them separate and keep that minus sign between them. And so in a sense, you have 2 separate problems here. We got a 3 and a cube root of, I'm going to grab 3 of them, 2 to the 3rd and cube root of 2 minus, and then we have a 2 on the outside. I'll grab 3 of these, cube root of 3 cubed, cube root of 3. And so simplifying further, we got 3 times 2 cube root of 2 minus 2 times 3 cube root of 3. 6 cube root of 2 minus 6 cube root of 3. And that's as much as we can do because the cube roots do not match. We got to stop there. So try that on 5. Try simplifying each one individually. We got 3 parts now. See what happens after you get that. Maybe some of them you'll be able to combine, some may not think. Yeah. Simplify as much as you can. Now on like number 3, we already knew the roots were the same. Yeah. It could have been simplified first, but if you know they're the same, you can combine them first. What did you guys get for 54 when you broke that down? So 3 3s and a 2. Okay. And then 16, we end up with 4 2s, right? Again, keep them separate from each other. Treat them like 3 separate problems until you simplify them. These are cube roots, so we're looking for sets of 3 things. And so here we're going to get 5 cube root 2 plus 3 cube root 2 minus 2 cube root 2. And now they're all cube root 2s. So all these match. So then we just work with the coefficients. So 5 plus 3 minus 2 is 6. Cube root 2 gives us our answer. Okay. All right. Try another one. I can see it. So on this one, 50 changes to 5 root 2. You got plus. Careful on the second one. Don't lose track of the 3 that's already in front. So you have a 3 in front already, and then you're gonna multiply out another 3, and you're left with the square root of 3 minus 7 root 2. Okay, so the first one and the last one share the same roots. So the first one and the last one we can subtract. 5 minus 7 gives me the negative 2 root 2. And then the middle one we just keep, and that is 9 root 3. And that's as much as we can do with that one. Okay. You guys remember this from Math 2? This was Chapter 1, Math 2, or Unit 1, Math 2. Yeah, we're doing more than that. All right. So now we're going to introduce some variables. Not much different. We're going to assume again that the variables are positive, so we don't have to worry about the absolute value. Okay, and then work through these. The 2x and 8x don't match, right? But the 8 we can break down. We can't simplify the first one anymore. The second one we end up with, we carry down that 5. We're going to take the square root of 2 times 2, which is 2. And we're left with the square root of 2x. And now, because the roots match, we can subtract the coefficients. The 6 minus the 10 gives us negative 4 times root 2x. Isn't too bad, right? All right. Try 8 and 9.